Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Hello everyone and welcome back to our physics class. Today, we are going to look at a really interesting question that explores the fascinating connection between electricity and magnetism. Let's dive right in and analyze the problem together. Take a close look at the figure shown here. We have a copper rod, labeled AB, which is suspended right between the two poles of a strong magnet. Notice how this rod is connected to a DC circuit with a battery and a switch. Now, here is the core question for part A. Imagine we turn that switch on. Electric current will start flowing through the rod. In which direction will the rod AB move? And what rule do we apply to figure this out? Let's work through the answer. When the current starts flowing, it creates its own magnetic field which interacts with the permanent magnet. This interaction causes the rod AB to move in the upward direction, right out of the magnetic gap. But how exactly do we know it goes upwards? The scientific rule we applied to determine this specific direction is called Fleming's left-hand rule. It's a very handy trick used in electromagnetism. Let's clearly state what Fleming's left-hand rule tells us. Hold the thumb, first finger, and second finger of your left hand perpendicular or at 90 degrees to each other. If your first finger points in the direction of the magnetic field and the second finger points in the direction of the electric current, then your thumb will naturally point in the direction of the force experienced by the conductor. Notice the capitalized letters F for field, C for current, and M for motion to help you remember. Great job on part A. Now, the question gives us an alternative option, part B. Let's switch gears and look at this second diagram. Sub-question A asks, can you identify which device is shown in this cross-sectional view? Let's uncover the answer for sub-question A. The device beautifully illustrated here is a moving call loudspeaker. You see these in radios, TVs, and your earphones. Moving on to sub-question B, we need to answer two things about this device. First, state the principle behind its working. Second, what is the exact energy change that takes place when this device operates? What makes this speaker work? The underlying scientific principle of its working is known as the motor principle. This is the very same concept that powers electric fans and water pumps. To properly state the motor principle for the exam, it states that a current-carrying conductor which is free to move, when placed in a magnetic field, exhibits a tendency to deflect or move. It basically converts electrical magic into mechanical movement. And what about the energy conversion? During its operation, the loudspeaker converts electrical energy directly into sound energy. The electricity from your audio player is transformed into the sound waves you can actually hear. Let's summarize exactly how it works step by step. The weak electric audio signals from a microphone are first amplified. These strong signals pass through the voice coil suspended in the magnet. According to the motor principle, this current-carrying coil experiences a varying force and starts to vibrate. Because the coil is attached to the large paper cone, or diaphragm, it also vibrates, pushing the air back and forth, and perfectly reproducing the original sound. That wraps up our detailed analysis of both the motor principle and the moving coil loudspeaker. I hope this explanation made the concepts crystal clear for you. Thank you so much for watching and happy learning.